Hi, I'm Ajitesh, and this is a demo of LangGraph. So I'm exploring different agentic frameworks. In the last one, I did Crew AI. In this one, I'll explore LangGraph. So what I'll try to do is to give you, I'll walk you through some of the concept that I learned and build a useful job description generator tool using LangGraph, and then I'll give like what are the things I liked and what are the things I did not like overall. Just starting from the basic, that what is agent? So agent, from my perspective, has three things. One is that it has a reasoning agent, which is LLM. Then it has a lot of tools that you can access to. And the third thing is it has a state, and using all three, it can do helpful things. So LangGraph concept is that you have to define a graph, and this graph has different nodes. Like one node could be LLM, which does the reasoning. There could be one node which is a tool that I want to search. There could be one node which is the start and the end. So using these two, you can create any application in the LangGraph framework. There is a nice how-to guide where you can go and build a chat application here in the tutorial section. But what we will try to do is to build a job description generator using Talavi as a search tool and try to understand the concept. So to start with, first we need to install certain libraries, which I'll do here. I already have put my keys that I will need in the Google Colab. So I'll need Talavi and I'll need OpenAI keys, which is here, and I will access from here only. We will need to do certain imports, which let me put here. And as it's happening, I'll paste the code to get the keys. Colab provides pretty nice way in which once you save the keys here, you can just use user data.get and the key name to get the key, and we can then set it as environment variable when you put here in the keys. By the way, I'm using Google Colab. It's freely available, so pretty nice to get started here. Let me put my image here. So now we have added the keys as well. You have to grant access, and once you grant access, you will see that this will show that we have accessed OpenAI key and the Talavi key here. So once that is done, then we define something called state here. So state is what is shared between the nodes from my understanding, and what we want is that the form name and the role, which will be the input from a user, and then what we'll do is a search to find certain relevant information and then generate the job description. So we define the state, then we initiate the graph, like instantiate it. Then we will define the first node of this graph. So first node is the input node where the user will add the input, and what we want the input is the form name and the role that they are recruiting for. Then we want the next node which searches about this firm, because you need to add a description that what this firm is about, and then what this role is about, like what are the roles and all. So that information can be from the state. Now, we could argue that LLM already has all the knowledge, at least for the role, so we don't need the second search, but just to be giving it more data point, we could do that. And of course, it's a demo. And the third node that we will add is the LLM. What it takes is, it takes the search result from the state. So we access the state here, state from search result, and the first search one is the form info, second search result is the result from about the role. This part should be really familiar to you, how we use in the LangChain OpenAI. And then we give a format in which it has to give the response. The prompt is a normal string. And we record this in the job description. So this is my third state, third node. And then what we do is that we connect the different nodes in the graph, define edges. So first one is the input, then we do the search, then we generate the description, and then we close it at the end. So once we do this, we can visualize the graph as well, but let's proceed for now. So this is the way to compile the graph. So we'll compile the graph here. Once we compile, we can visualize like what is our graph. So you can see that our graph starts with start, when then user gives the input, and then we do the search and finally perform the job description. Now once these things are done, we need to write the real function here. So what I will do is define an user input. So this is the first input of the state, and RGI is the company that I work, and we want to hire for software developer role. And then what we need to do is to, in my case, I'm doing invoke. You can also do a stream and get the results. So first it will do the search, and then finally it will get the result for us. Once the result comes, we will print. So this will be in the form of OpenAI result. So what we'll have to do is to do dot content and then present the result. So this is the job description. So overall, this is the very easy like straight node that we wrote. There was no cyclical thing in between, but you can have human input and all other kind of node here. we will convert, let me convert this into then an application that I created. So let me do that. So this is the LangChain demo that I created. So here what I did was I just added, and I'll put the description for this in the YouTube video as well. So in this case, what I created was this file generate ArchAI demo, and we defined the state, we put the input, the search node similar to here, and then we defined a function which is LangGraph. So this puts a wrapper around it that what we want to get input from user is the firm name and role, and then we write the file in this job description.md file. So I ran this function before, and this is what it created in MD form in sort of markdown format, the job description. So you can run it with Python Python command. Then I also created a Streamlit demo of this app. So what I did was that we get the input from here. This is just some boilerplate like markdown, create a title and all. And then we get the input from user, which is the job description and title, which is the firm name and the role here. And then we give a two column. One column we generate the text, and another column we give an option to download. So you can run this file from the terminal, which let me do here. So I got my terminal, and the command I need to run is Streamlit run here, which I have already run before. So this is a nice interface which Streamlit provides. So I want to hire for ArchAI only, and I want to hire software developer. So I could hit generate description, it will do the search, and then finally give me the output. So as it generated the output in the markdown format, and we also have this option of raw text, and then the option to download text here or download as a markdown. So Streamlit provides an easy interface. So I'll put this code as well. But now stepping back, like what are the things I liked and did not like about the framework? I think what I liked is that it's very well documented. Like I went through CrewAI, that also has good documentation, but it is very clear to me what LangGraph was trying to do. This graph aspect was a bit complicated to understand initially. This is opinionated way to do things. So you have to understand, okay, what is the graph, what is the node, in comparison to CrewAI, where the agent task is much more intuitive framework that, okay, there will be some agent, it has to be assigned a task, and you instantiate at the agent and the task. This took me some time to understand, okay, what is this node? Because node can be start node, end node, it could also be way where LLM occurs. So node is not the agent, it's their own interpretation or own concept. So that was not very intuitive at first, but when I found it, I think it gave me a lot more control into what I want to do, where I could insert human input, where I could start and end, which I did not get in the CrewAI. So I think there is some downside and upside of doing things this way. Overall, stepping back, I think across all these agentic framework, what I don't like is there is abstraction that you operate at, and you don't exactly know what is going into system prompt, user prompt, which I will give some credit to LangChain here, is that in writing we know that because maybe we are aware of LangChain, we know that what is growing in the prompt here, and because this is the LLM prompt, we know what we can write in the system prompt and user prompt. So that was helpful, but then you have to understand all these graph nodes and all. And basically what we are doing is very simple. If you just want to write Python function to do that, you will write one function for here, and you will write one Talavi tool and one function here. So writing your code on your own also could be pretty straightforward. So it introduces a lot of these abstractions. The positive side of it, I think across these agent framework, what we get is a nice set of tools. I think that is pretty helpful. Like I would have gone to Talavi and ran and read all this documentation and all, and they make it pretty easy for me to use. So I think tools is the real winner that we get in building these demos. And the second thing we get is the nice wrapper on LLM. So I don't have to worry about OpenAI, ChatGPT, and all of these. I can just use LangChain there. So these two are benefits of the abstraction, but adding these nodes and understanding their concept is a bit investment and could also be limiting, because we would want to directly know that what is going to the LLM and how we could control each aspect of the flow. So that's my take. Hopefully this was helpful. Let me know in comment in this video. Thank you so much.